All right. All right. So, have you guys ever done this before? Yeah. So, kind of a review. Okay. So, we're doing, yeah, long division of polynomials here. So, the first thing that I want to point out to you is that, do you notice that uh, underneath the square root, I have all of my degrees lined up? Do you guys see that? That's very important. I have first degree, and then I have x to the 0 degree here, right? It's very important that we line all those degrees up. That's going to play a role in later on in our little lesson here. And what is the degree of the big polynomial underneath the square root? A degree of 3. Very good. And what is the degree of this part on the outside here, this x minus 2? 1. Very good. It's important that that's smaller because that's going to play a role into it. Okay. So who remembers how to do this? Yeah, Grant.
I was going to ask, is it supposed to be 4x or just 4?
Oh, thank you. It's just 4x. Thank you. So, what's my first move here? What did we do over there? We asked how many times does 3 go into 6, right? So, Annie, what do you think our first move is going to be here? Yeah. Very good. How many times does x go into 6x cubed? And the answer would be? 6x squared. Because 6x squared times x gives us the 6x cubed. But what about this negative 2? What do we do? Yes, I also multiply 6x squared times negative 2, which would give me a negative 12x squared. Then, just like before, we drew a big long line, and we're going to subtract all of this. Now, notice I'm putting parentheses around the entire new portion of my problem so that you remember to distribute that negative sign. Also, notice that I'm keeping my columns lined up. This is my column of third degree powers. This is my column of second degree powers. This is my column of first degree powers. Okay? So it's important that we keep this lined up as we move through this problem here. So I'll erase all this so you can see it. All right? All right, good. So let's see here. 6x cubed minus 6x cubed. That gives me nothing. That's good. 19x squared minus a negative 12x squared would give me how much? Negative 7x squared. And then we would bring down the positive 16x, right? All right, now we repeat the process. How many times does x go into negative 7x squared? Negative 7x times. So negative 7x times an x gives us negative 7x squared. Good. Negative 7x times a negative 2 gives us a positive 14x. We're going to draw a line here. We are going to then subtract. So we're going to get 0 here by design. We're supposed to get 0 there. That's how it works. Good. And then 16x minus 14x, what does that give us? Yeah, positive 2x. And I bring down the negative 4. Can I keep going?
Yeah.
How do I know that I can keep going?
Plus 2, or multiply by 2.
Well, here's how I know. Okay, so I started off with a third degree polynomial. Then I got a second degree polynomial. Now I'm down to a first degree polynomial. So I can still keep going because I'm dividing by a first degree polynomial outside. So if I keep this going, x goes into 2x how many times?
2.
Positive 2, so 2 times 2x. Oh, that gives me the 2x. Great. 2 times negative 2?
Minus 4.
Negative 4, and we subtract. We get nothing there, and negative 4 plus 4, oh, gives me a 0 down there. Oh, I got lucky. All right, so now back to the clouds that I drew before. Okay, see this part right underneath here?
Yeah.
This part has a name. What is the name of this?
Dividend.
Dividend. There you
Oh
go.
my gosh, you just guessed.
Very good. That's your dividend. What is this piece out here? The divisor. Very good. Good. Yeah, what do you call this piece up here?
Quotient.
Very good, because there's yelling out the answers here. This is the quotient. And this piece down here, right, is going to be our remainder. Logarithm, yes. Yeah, there's the division algorithm. So let me give you an example, right? Let's do an easy one. Let's go back to third grade for a second. Let's do 37 divided by 4. All right, if I did 37 divided by 4, what would you do first? Yeah, well, doesn't go. So we'll go 9 times. That'll give us 36. That'll give us a remainder of 1. Okay, good. So my dividend is 37, right? 37 is equal to my divisor, which is 4, times my quotient, which is, what's my quotient, guys? 9, right? Plus my remainder, which is Is that true? Really? 37 equals, oh my god, 36 plus 1. Yeah, check it out. 37 is equal to 37. No way. So it turns out this is an algorithm. So we can say the dividend is equal to the quotient multiplied by the divisor and then added to the remainder. Pretty sweet, right? So that means dividend over the remainder, or dividend minus the remainder, excuse me, equals quotient times divisor. So we can manipulate this however we want, but there is a division algorithm that I wanted to make sure that you were aware of. Why would we even want that? Why would that even be interesting to have? Yes, very good, Bobby. It will allow us to check the things that we need to check. So here we go. I would like you to divide and check. All right. And the one I want you to do is this one right here. There we go. In your table groups, let's do x cubed minus 1, and I want you to divide that by an x minus 1. Okay, what do you have to be careful of to set this problem up? The dividend is not written in standard form, right? Okay, put that thing in standard form. All right, so some people were stuck. They didn't understand the setup here. So check it out. I've written in placeholders for you because we need those when we're going to start our division, right? So you have to make sure your dividend has all the correct placeholders, right? All right, so I'll help you out. How many times x going to x to the third?
X squared.
X squared times, right? X squared times x?
X cubed.
All right, so the third, x squared times negative 1.
Minus x squared.
So isn't it important?
To add
Yeah. And we're going to subtract these. So x cubed minus, that's giving me 0. X squared minus a negative x squared is
x squared.
positive x squared.
Plus 0 x.
Oh my gosh. All right, so does x go into x squared?
Yeah.
How many times?
Add x.
So x times x gives me x squared
X squared plus
minus x. Good.
times it by negative, and then 0, and then plus x, so it's x.
Okay, good. Then what?
Drop down to 1, so it becomes, and then it's just plus 1, and then it'll be x minus 1, and then times that thing by,
There you go.
and then use 0.
Okay, so check this out, you guys. So that means that x cubed minus 1 is literally equal to x minus 1 times x squared plus x plus 1. Does this look familiar to anybody at all? No. Does this look familiar to anybody at all? That's the difference of 2 cubes. And this is the formula, and that's where we get it. Holy cow, crazy. Mind blown. Okay, is this actually true? Is this actually true? Does this actually work? So this is my this is my dividend and this is my divisor. My remainder is 0, so if I add a remainder of 0, so I would add plus nothing to this on the end, right? Okay, so if I actually multiply these out, you see that I do indeed get x cubed minus 1. So let's go ahead and do it really quickly. What's x times x squared? X cubed plus x squared plus x minus x squared minus x minus 1. What happens right here? So look at that. 3 plus x squared. All right, so notice for this example, I want, before you guys go out on your own and try this, you're going to have to do some work to rearrange the terms of the dividend and the divisor. All right, so that's a little hint to you. All right, how many people forgot to put the 0x cubed in? Yeah, when you first do it, you might forget to put the 0x cubed in. Make sure that you put that in before you begin your work there. So that one part needs to be a placeholder for us. Yeah. Someone's out right now. You gotta wait. Okay, so here we go. You guys follow along? Okay, cool. So negative 4x cubed plus a 4x. This gives me 0 by design. X squared plus this would be 9x squared. And 3 minus 12 would be a negative 9x. And then bring down the negative 2. So it looks like I'm going to have a positive 9. 9 times x squared gives me 9x squared. 9 times 2x gives me a positive 18x. And then 9 times negative 3 is a negative 27. And we are going to subtract, get nothing. Negative 9 minus 18, that's my negative 27x. And then negative 2 plus 27 gives me a positive 25. So therefore, my answer can be represented two ways. You can just say, there's the quotient, there is the divisor, and this is the remainder, no problem. Or you could have written it like this. You could say, the dividend, 2x to the fourth minus 5x squared plus 3x minus 2 is equal to 2x squared minus 4x plus 9. That's your quotient. Plus a negative 27x plus 25 all over x squared plus 2x minus 3, or minus c. So synthetic division is another form of using a way to divide polynomials, but it's very, very limited. I tell it to all of my students, okay? You can only use it when you're dividing by an x plus or minus c. So in other words, when we're talking about a binomial with a degree of 1. Okay, so that's when you can use it. And the way that you do it is you take the opposite of c. And the c that I'm talking about is this c right here, whatever c is right in there. So, okay, since you guys have never seen this before, I'm going to give you the old way and the new way. So this is the long division way. And then synthetic division. All right, so let's say, for example, we want to do x to the third plus 4x squared plus x minus 1, and we're going to divide it by an x minus 3. Okay, so x goes into x cubed, x squared times x is x cubed. We just did this, right? So negative 3x squared. Then I'm going to subtract here, get 0. So 4x squared plus 3 is going to be 7x squared. Bring down my positive x. So that's going to be plus 7x. So 7x squared, and then what, minus 21x. So subtract, getting 0. And this looks like 22. I'm doing this one kind of fast. Am I doing it right, you guys?
Oh, yeah.
Yeah, okay. X goes into 22x how many times? Positive 22. And that would give me 22x, and then what, minus 66. Is that true? So I'd get nothing there, and then negative 1 plus 66, how much is that? 65. So my remainder is 65. Okay. Woo, lots of the CPU power being used. Cool. We love it. Go away. All right, so let's compare that to a new way of doing division, and take into account I am dividing by x plus or minus c, so I'm good to go there. So I'm going to take the opposite of c. So in this case, the c value is represented by a negative 3. So I'm going to take the positive 3. All right? I'm going to write down some numbers. The numbers I'm going to write down are here. 1, 4, 1, negative 1. Where did I get those numbers from? Nelson, what do you think, buddy? Oh, yeah, okay, wait. So this is the representative of the opposite value of c right there. Okay? So my next question is, where did these numbers come from? 1, 4, 1, negative 1. Does anybody see that in the setup over here? Amy, where is it? Yeah. Yeah. It's the coefficients of all my terms, right? Good. So then I'm going to skip a line and draw a line. And I'm going to bring down my 1. Okay? Bring down my 1. So here's what I'm going to do. I'm going to multiply 1 times 3. So 1 times 3, what's that going to give me? 3. I'm going to put it right here. And I'm going to add 4 and 3 and get what? 7. Good. I'm going to repeat the process. What's 7 times 3? What? Put it right here. So what would I get now? A 22. And then 22 times 3? 66. Put it right there. Add those two together. What do I get? Okay, does anybody see anything crazy happening here? Check this out. A 1, there's the 1. A 7, holy cow, there's a 7. a 22, holy cow, and to top it all off, a 65. Oh my god, there's a 65 down there. So this part right here, you need to know what you're looking at, right? At the very end, I always put another box around it, okay? And this is going to represent your remainder. And then I work backwards. So the 22 represents the constant, which is my constant on the end here. The 7 represents the leading coefficient for the x term. And then the 1 represents the leading coefficient for the x squared term. Okay, so I work myself backwards. So I can see that when I divide this, I get an answer of x squared plus 7x plus 22 with a remainder of 65, which is exactly what it says over there on that side. Okay, so it's just procedural based here. I would like to do another one, an example here, just so we get the procedure down, okay? Before we start to get into like how we use this stuff, okay? So this is an extension of box 5. Let's do this one. Let's do 3x to the third minus 7x squared plus 2x plus 3, and we're going to divide that by x plus 1. And I want to use synthetic division to do it. So am I even allowed to do synthetic division, you guys? Yes, I am. How come? Because I'm dividing by the right proper form. So I'm going to take the opposite of c. So in this case, c is represented by a 1, so the opposite of that would be negative 1. I'm going to set up my leading terms. 3, negative 7, 2, 3. Skip a line, draw a line. And bring down the 3. And we're going to add this stuff up. So 3 times negative 1, negative 3. Add them up. Negative 10. Multiply them. What? No. Multiply 10 and negative 1. 10. Add them up. 12. Good. 12 times negative 1. Negative 12. Add them up. Negative 9. Okay. So what is my remainder? My remainder is negative 9. This represents my constant. This represents x. This represents x squared. So this has an answer of 3x squared minus 10x plus 12 minus 9 over x plus 1. Ooh, look at that little fancy bit on the end. Yeah, that's why I'm going to give you a function. Okay, let's say I give you a function f of x is equal to 3x to the third plus 8x squared plus 5x and then minus 7, okay? And let's say I would like to divide this particular function by an x plus 2, okay? So on the left-hand side here, we are set up to use synthetic division because we're dividing by a binomial. So I'm going to go ahead and set up negative 2. And I'm going to put 3, 8, 5, and a negative 7. Skip a line, draw a line. Bring my 3 down, and I'm going to add straight forward here. Okay, so 3 times negative 2, what do you get? Negative 6, good. We're going to add this together. What do I get here? 2. 2 times negative 2? Negative 4, good. Add this up. What do I get? 1. 1 times negative 2? Negative 2. Add this up. What do I get? Negative 9, right? Okay, so my remainder is negative 9. And I can see when I divide this out, I'm left with 3x squared plus 2x plus 1, right? So far, so good? Okay, on the right-hand side here, could you please evaluate for me f of negative 2? What am I asking you to do here? What's f of negative 2? Yeah, plug in a negative 2, right? So literally just like 3, negative 2 to the third, plus 8 times negative 2 squared, plus 5 times negative 2, and then a... Oh, you just got negative 9. Okay. Okay, so anybody notice anything strange here? This is equal to negative 9. What the heck? How is this even possible? Okay. Whoa, mind is blown. Okay, so check it out. I want you to make the connection that this and this, there's a relationship there. And I want you to make the connection that this right here and this right here, there's a relationship there. It's not a coincidence that those two things are going to be the same, all right? So, right there, there's a connection with those things. So the remainder theorem says, okay, if you have some polynomial and you're dividing by x plus or minus c, you can find the remainder by simply evaluating the function for that point. How crazy is that? So, if I were to ask you guys, all right, let's take that same function and I want to divide it by an x plus 5. What could you do to quickly find the remainder? Just evaluate f of negative 5. You punch it into your calculator, you get some answer, and it will be the same thing as doing synthetic division and getting the remainder left over. How crazy is that? That's what the remainder theorem is telling us, okay? But the remainder theorem is sort of tied to synthetic division here, okay? So whenever you can use synthetic division, you can also use the remainder theorem, all right? So if I ask you, hey, find the remainder, all you got to do is evaluate the point at that particular value, right? All right, that's one of our theorems here at the end of the day. Okay. The other one is the factor theorem. All right. So we're going to talk about that right now. And these things are all related to each other. All right. Talk about the factor theorem here. So the best way to do it is to just go ahead and give you an example. All right. So I'm going to give you a function, and the function I'm going to give you is f of x equals 2x to the fourth plus 7x to the third minus 4x squared minus 27x and then minus 18, all right? And I want to divide this function by x plus 3, okay? Could you please, on the left-hand side here, go ahead and do synthetic division? And all right. You should be getting somewhat close to that. When you are done, take a look at my answer and see if your answer matches my answer. How many people are on board with that? Special, okay? So you should have discovered that by now we ended up doing this little synthetic division and we got a 0 in the remainder, right? So that means that if I choose to apply the remainder theorem and I evaluate f of negative 3, what would I get, you guys? 0. I would get 0 as well. So I can see that the remainder theorem will also tell me that f of 3 is going to give me 0. The fact that I have 0 in my remainder from synthetic division or from the remainder theorem tells me two things that are very important, okay? Number one, it tells me that negative 3 is an x-intercept. What? How can that be? Negative 3 is an x-intercept, and it tells me the second thing, that x plus 3, the original thing that I started with, you guys, that thing is a factor of f of x. So that means it can actually be factored out. It is a factor of f of x. These two things right here make up what's known as the factor theorem, okay? So if you get a 0 in the remainder, from synthetic division or using the remainder theorem, it tells you two very important things. It tells you that x minus 3, or it tells you that whatever you evaluated is an x-intercept, also known as a 0. And it tells you that x plus whatever you had there is a factor of f of x. So right now, what I want you to do is I want you to graph this function in your graphing calculator, and we're going to examine the graph. Yeah? Good? Everybody good? Okay. Let's start plugging this in here. We're going to go 2x caret 4 plus 7x math cubed minus 4x squared minus 27x and then minus 18. All right, everybody, Zoom 6 this thing. Zoom 6. Well, Zoom 6 makes sure we're all in the same window so that everybody's calculator looks the same. Okay? Okay, guys, let's make a few connections. Let me throw you back to last week. This function, what's the degree of this function? Odd or even? Even. And what is the leading coefficient, positive or negative?
Positive.
So can you tell me the end behavior of this function? Up left, up right. Oh my gosh, look at the graph. Is it going up, left, and up, right?
Yeah.
Holy cow, right? So we already knew that. Now, how many zeros can this function have? Up to how many? Up to 4. Count that. How many do you see? 1. I see 4. 1, 2, 3, 4. Oh my gosh. How many turning points can it have? At most 3. Oh my god. 1, 2, and there's probably one way down here. Holy cow. We just had like 3 weeks of math come into one problem here. That's pretty darn cool. All right. So now, let's check in fact and see if -3 is a 0. How can we do that? How can we see if -3 is indeed a 0?
You can check, go to second calc.
Yeah, exactly. Let's go second calc, and let's check a value. So if I plug in x is equal to -3, look what it gives me out. Bam, a 0. All right, ladies and gentlemen, I would like you to investigate and see if you can find the other 3 zeros. Okay, so let me head back to this. Okay, so you guys did some investigating, and you found that when you checked, what'd you check? -1.5. So negative is that 1.5? Okay. Yep, that gives you a 0. What else did you find?
-1.
So let me write that down. So the zeros so far that we have found here, we found -3. What else did we find? -3 halves. Okay, what else did you guys find? -1. So when I plug in second calculate, value -1, yep, that gives me a 0 as well. Okay. -1, and then I'll trust you 2. Okay, good. So I'll trust that the 2 is also there. So if these are my zeros, can you guys give me the factors then? If -3 is a 0, what's the factor going to be? Yeah, so if -3 is a 0, then x plus 3 is a factor, okay? If this is a 0, what's the factor?
2x.
X plus 3 halves, very good. If this is a 0, what's the factor? X plus 1. If this is a 0, what's the factor? X minus 2. Hey, guess what happens when you multiply all that together? What do you think you get? You probably get that right there. Oh my god. So really, we're just learning how to factor big, nasty, gnarly polynomials. Oh my god.